Voyager 2 crossed Neptune once and sent back more than 9,000 images. One famous view showed a dark storm about as wide as Earth. 5 years later, Hubble looked again, and the picture no longer matched. So what did our only close visit really capture? That single visit came on August 25, 1989. No spacecraft has studied Neptune up close since. But the 9,000 images did not come from a quick burst during the few hours around the planet. Voyager began watching Neptune in early June, while it was still far away. The campaign continued through the close pass and into October. Across that wider encounter, Voyager returned more than 9,000 images of Neptune, its rings, and its moons. Before Voyager, only 2 Neptune moons were known, and the evidence for rings was incomplete. This one encounter had to turn distant hints into direct evidence. The spacecraft had launched in 1977. Neptune was the last stop in a 12-year run across the giant planets. There would be no second pass if the camera, pointing, or data link failed. The route depended on timing. Voyager used a rare outer planet alignment that NASA says comes about once every 175 years. It opened gravity assist opportunities. After Uranus, that planet's gravity bent Voyager onto the road to Neptune. Now the camera problem became serious. At Neptune, Voyager had only about 3% of the light it had during the Jupiter encounter. Some exposures lasted around 15 seconds. Others ran for minutes. But Voyager was still moving. A long exposure from a moving camera can smear the target, like a night photo taken with a shaking hand. Engineers programmed the spacecraft to compensate for its own motion while the shutter stayed open. That kept the faint target clear instead of dragging it across the frame. The problem did not end when the picture was taken. On Earth, the deep space network was made more sensitive so Voyager's weak signal could still be heard. That is the first answer hidden inside the title. The archive was not one lucky burst. It came from a rare route, careful pointing, long exposure control, and giant antennas listening on Earth across a campaign that lasted months. Then the engineering gave way to the planet itself. From far away, Neptune looked like a small blue disk. Up close, the images showed a world in motion. The great dark spot stretched about as wide as Earth. Bright clouds gathered near it, high above the main cloud deck. Those white features were clouds made from methane ice. The dark spot was not a hole in the planet. It was a huge storm moving through Neptune's atmosphere. Voyager did not take only one famous portrait. Real image sequences showed cloud shapes and storm details changing over days. Neptune's winds can race faster than 1,200 miles per hour. One still frame cannot show that speed, but the sequence changes the story. A planet that looked smooth from Earth had fast weather, bright high clouds, and giant dark storms. It was active during the encounter itself, but the planet was only half the encounter. Voyager turned uncertain hints into direct images of a dark, dusty ring system. Some material was not spread evenly. It formed distinct arcs inside the outer ring. Scientists think the small moon Galatea helps keep some arc material from spreading out. Then the magnetic measurements made the system look even less tidy. Neptune's magnetic field is tipped by about 47 degrees from the planet's spin axis. A simple model of that field also places its magnetic center far from the planet's physical center. This was not a neat system arranged around one simple pole. The encounter had opened an off-balance world, and the strangest target was still ahead. About 5 hours after Neptune, Voyager reached Triton. Triton is Neptune's largest moon, but it moves the wrong way around the planet. It circles backward compared with Neptune's rotation. That odd orbit is a key clue behind the idea that Neptune captured Triton from the Kuiper Belt. The Kuiper Belt is a region of icy bodies beyond Neptune. Voyager did not film that capture. Scientists built the idea from the orbit and other evidence. Triton's surface sits near -235 degrees Celsius. It has few impact craters, so much of the surface looks young or reworked. A world this cold should have felt frozen in every sense. Then Voyager found dark, geyser-like plumes rising several kilometers above the surface. The engine behind those plumes is not fully settled. Sunlight may warm material below clear surface ice and build pressure. Heat from inside Triton may also help. What matters is that an extremely cold world was showing active change. Triton had entered the mission as one moon among many. It left as a captured world mystery with fresh-looking terrain and active plumes. The moon had stolen the final act. As Voyager moved away, it looked back and caught Neptune and Triton as thin crescents. The close visit was over. But one question remained. Did those 9,000 images show what Neptune is, or only what it looked like at that moment? Voyager left behind an iconic portrait, a blue disk, the Great Dark Spot, and a second major dark storm. Then time moved on. 5 years later, Hubble looked at Neptune again. Both major storms from the Voyager pictures were gone. Later, Hubble monitoring found other dark storms appearing and fading. That does not mean Voyager was wrong. The spacecraft caught a real planet at one point in a changing weather story. The famous dark spots were huge, but they were not permanent landmarks. This is the strongest answer to the opening question. More than 9,000 images can transform a distant blur into a world. They can reveal clouds, storms, rings, moons, magnetic fields, and frozen ground. But even a giant archive from one encounter is still one time slice. Voyager did not bring home a permanent portrait of Neptune. It caught one chapter of a planet that keeps changing. Humanity has never returned for another close look. Hubble can watch from far away, but the only close archive still comes from 1989. One route, one pass. More than 9,000 images. Voyager solved the camera and signal problem. It revealed violent weather, dark rings, a tilted magnetic system, and an active Triton. Hubble later showed why the story was not finished. The most famous storm portrait had changed. Our only close visit gave us the best close-range snapshot of Neptune we have ever had. It also showed why one snapshot can never be the whole planet. Subscribe to Blink Facts for more deep dives. If Triton deserves the next one, tell us below. Then keep exploring with the Voyager story on screen.